again, everyone. After a long absence, welcome back to a new Kalili-oriented programming mini-series. That's right, a small 12-day series on a bunch of esolangs, esoteric programming languages. They're fun, they're easy. And we're going to start it up with the OG two-dimensional programming language, Befunge. Now, Befunge was originally a typo of the word before, but seems to have owned it afterwards and was invented in 1993. As you may know, in a traditional programming language, you simply write your statements in a linear order, and you expect the interpreter to read them line by line in order and execute the code. But have you ever thought that this one-dimensional input mechanism and interpretation was maybe a bit too linear, maybe wasting a whole dimension of space? And for this demo, we'll be using the wonderful Befunge website at amicloud.github.io, which is a fun little IDE made specifically for Befunge. So thank you, whoever made that. And now the thing about Befunge is that it is, first of all, a stack-based language, which might be familiar to those more who know Forth. If you don't know Forth, check out the video. And a stack-based language basically means it takes whatever is in the input at the program counter and puts it in the stack, or otherwise manipulates the stack. So for example, if you write 6, 6, that'll each put 6 in a stack, and then write plus to add them together in the stack. So, and then you can end a program with the @ sign. We go to interpreter mode here, and step, there we go, 6 is in the stack over here, step, another 6, step, that was the add instruction, so it became 12, and step, and that's the halt. So that's how you add numbers together. And we can also use the dot, kind of like in Forth, to output. So this is our stack over here, and this is our output. So our output was 12 for that. Easy enough. So now let's try to demonstrate the directionality of Befunge. So in this case, we were just starting from the left and moving right, like a traditional language. But instead, we can use the arrow to say, hey, start moving left. So if you start taking tokens in from the left, and this is what that would look like with just hitting crawl here to step through the instructions slowly, and it immediately ends. So if you want to move the flow that way, you probably want to do your writing this way. So this is that same program, but written with leftwards flow. Easy enough. 12. All right. So now you can actually see a pretty interesting use case of the leftwards arrow. So let's say we want this string, right? Hello world. So hello world is each of them a character, and then you can use a quote operator to go into string literal mode, which basically means just literally put each of these into the stack instead of interpreting them as a command, and you can use the quote again to escape literal mode. So if we just put that @ sign here, and we crawl, we want to demonstrate. So the way you print an ASCII character is just the comma. So if we go like this, we're seeing hello world backwards, because as stuff goes into the stack, it's building backwards. So instead, what you could do to keep it readable, I mean as readable as Befunge code is going to get, is do something like this, right? And put the @ sign here. And so now we're going to start flowing left. So these are going to be put in backwards. Then we're going to start printing them forwards. And then we're going to get hello world again. Right? Pretty cool. Pretty cool. Because you're still, the stack still builds regardless of the direction in which you're flowing. So you can actually flow like that. And now maybe if you want to see that all these commas kind of look silly, and if you change the length of this string, those commas are going to look different. So we can up the technicality a bit and start using both directions in a single program. Alright, and so we're going to need a few more commands from Befunge, and after this there's only a few more, and then that's it, that's the whole language. So we've got the colon command, which just duplicates the top of the stack, the hash command, which skips the next command. So if there was a hash here, for instance, it would always skip this @ and go straight this way if the flow was left. And we've got the underscore, which basically says if you're moving, then it'll pop the top, and if the top is a 0, then it'll start moving right regardless of the direction that you were in, and otherwise it'll keep moving left. So that's called the horizontal if. That's the if of direction. So now with that out of the way, let's see if we can rebuild this without all those commas. And so what we're going to want to do first is print, right? But then we don't want to stop printing and then go put the whole thing on the stack again. So we'll push it back, and then we'll push this back, and now that'll just be caught in an infinite printing loop, right? And just to demonstrate that, so we got it in, then bang, 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 which is great and all until we run out, and now we're just in an infinite loop. So instead of doing that, what we can do is put a @ sign here, and then use the horizontal bar. Also, we don't want to, which is good, but now when we hit the crawl, we can see that every time this horizontal bar action is running, it's actually deleting something on the stack, because the thing that it checks is that. So instead of letting all those checks ruin the system, we can just put a colon there to duplicate whatever's on the top of the stack. I also want to put another duplication here because on the way in, the H is getting deleted. We're going to want to put a duplicator here, but we're only going to want to do the duplication if we hit this comparison. And you know that comparison is going to send you this way, so we'll just put a jump over here so that it'll jump over it if it's coming from this way. Hopefully that makes sense. Now we'll just go like this just to show you guys that it works. And here it is, the whole bouncing going back and forth. This is that conditional if. Once it hits the zeros on the stack, and that's just the way it goes. Alright, so that's Hello World in Befunge, but we haven't even gotten to the good part, and that is the two-dimensional part. Check it out. The way the two-dimensional part works is a lot like what we've already seen, except we can start pointing the arrows in any direction. So if we wanted to, we can start pointing right, and then put a whatever into the stack, like this, and then we can start pointing down with the point arrow down, which is just a V actually. Then we can go right here and start pointing this way. We could put a few commas here. We can start pointing down again and come here let's say we want to point left, turn these into commas, and then go down. Actually, let's just keep going. It'll keep going left. It's going to loop back around. And why don't we put the end over here, just to show you guys what's going on with that. And I'm going to put that over there. So that's a pretty strange looking program, actually. But let's see how it works. Let's go to the interpreter. And here we're going to step, go forward, put these into the stack, boom, go down, then it hits the left arrow, starts going left, printing, boom, go down, hits that one, comes back around, and ends a program. So now you've seen this is a real 2D program with all these little arrows pointing to each other. And you know if you miss an arrow, then you gotta loop back around. So that's pretty interesting. So you can actually rewrite the hello world a little bit more, I don't want to say clean, because Befunge is not a clean language, but a little bit more interestingly. So you can start the same way, go hello world, put it in backwards, so going left this time. Then you can just go down instead of left, and the position. What you can do is just go right, print, down, and here in the down you can use a new command. And it's the vertical bar. It is the vertical bar. So the vertical bar is much like the horizontal bar that reverses directions if the top of the stack value is 0. Or namely, it only goes down if the top value is 0, otherwise it starts moving the flow of program upwards. So now we've got try to follow this in your head here. We're going left, putting all of this in the stack, going down, going right, printing the first thing in the stack, going down, going left, duplicating the first thing in the stack. And the reason I want to duplicate this is because we want to use a bar. And then the bar is going to go up if the top stack is not 0, otherwise it's going to go down. And if it's going to go down, let's make it halt. See how that works? Go down in a little loop, boop boop. See the little square going. And there we go. And it halted. It always halts one after, but see, pretty cool. Now we can write the hello world a bit more cleanly, because it's interesting. There's no for or while or until. There's no looping constructs in Befunge, but you can use these little arrows to make little squares where the program counter gets trapped until a certain value happens. So it's pretty interesting. Alright, so the next two final big things in the Befunge arsenal are the G and the P operators, which are get and put. They basically manipulate the field. So the field is where you're writing your Befunge code, and it's indexed from the top as 0, 0 here, and it's XY. So the X goes up to N, 0, and then the Y would comment like that. Anyways, so that's how the field is addressed. So what you can do is write 0, 0, and then that's the X and the Y, and you can put something there with the P. So what would you want to put? You can put a number there, so you can put a 1, or you can go string literal, and let's say we'll put the @ in there. So then you write P, so that's saying this is the X and the Y, and this is what I want to put at XY0. XY0 is here in the field. So if we go here, there is no halt, but if we go forward, we got the halting sign in the stack, the coordinates from the p command, and the @ sign has been changed. And so it halts the program. That's the beauty of the p command. And the g command is sort of similar, except instead of putting the symbol there, it takes just these first two coordinates and returns and puts on top of the stack the character code for this right here. And so we can just end the program like that. And this is the character code for a quote, a double quote. So that's how those work. And the reason you might want to use those, other than self-modifying code for crazy Quine-like behavior, is you can also use it as a secondary storage. So you can store numbers in the field, let's say somewhere where you're not going to touch them, where the field movement doesn't really touch. So you can just use it as a secondary storage, because the stack is a bit limiting and you have to keep in mind what's on top of the stack and what's underneath the stack and whatever. Let's put the first Fibonacci number into the field. Let's put it here. So this location is 0, 1. So we're going to take a 1 and P to put it there. And then we'll put a 2 at 0, 2 and put that there. So that looks good. And now let's use the V to come down and start going to the right here. And we're just going to get those numbers back. So it's going to be 0, 1, get. But remember that you have to read it in like this. And same with 0, 2, get. There we go. Now that we have 0, 1, and 2, let's come down here, because we don't want to hit this, because this is our storage area, and so is this one. This one's going to be a 2 at the moment. So let's start moving back to the right. And now that we're moving back to the right, we have stored these two successfully in this area. We're going to add them together because we used the get to pick them back up, put them in the stack. We'll add them together. Then we'll duplicate it because we're just about to output it. That's the $sign. And then let's output a space. ASCII code for a space is 32. So then we're going to do 4, 8, and the multiplication times sign for the 32. Then we're going to have a comma to output just the space. And then we're going to, now that we have all of these, we have to now put whatever's at the top of the stack, which is the addition of these two. Remember, we put that at the top of the stack, back into the storage over here. So we're going to say actually 0, 2, get that. And we're going to 0, 1, put that. Then we can move movement upwards, move it sideways, and then go 0, 2, put. There we go, and that is the series. Let's just make it run a little bit faster. Alright, and pause. And looks good to me. So there we go. That is the Fibonacci series written in Befunge. There's a lot of interesting stuff you can do with Befunge. Namely, their quines. Like, you can get very creative with the quines. It kind of reminds me of these sort of like learning coding games where it's on a grid and you put the commands down and see what the character does. This character almost acts as a sort of instruction pointer. Although the instruction pointer is linear in this area, it kind of has the same vibe to it. And I think Befunge is an interesting, take on that. And it might be an interesting way to learn how to code Although I probably wouldn't recommend Befunge to any beginner or anything, it's still a really interesting language. Overall, I would rank Befunge as my current favorite esoteric programming language, going on top of the cow programming language, which is the only other one that I've done so far. Stay tuned for a new language.